Today let's take a look at section 7.2 on applications of linear equations. The big item we need to deal with here is translating words into mathematical expressions. And we have several verbal expressions that would indicate addition. The word sum, such as the sum of a number and 5, would be translated as x plus 5. 8 more than a number would be x plus 8. 2 plus 7. 3 added to a number, 3 plus x, and a number increased by 10, x plus 10. So all of those indicate addition. Next we have subtraction. 8 less than a number would be, or 5 rather, less than a number would be x minus 5. Notice the minus 5 is coming second. 5 less than a number. So we're starting with the number and subtracting the 5. 9 minus a number, in that case the 9 comes first and then it's minus x. A number decreased by 8 would be x minus 8. The difference between 20 and a number would be 20 minus x. And then a number subtracted from 16 would be 16 minus x. Moving on to multiplication, we may see 9 times a number. That would be 9x. A number multiplied by 6 would be 6 times x. The product of 17 and x would be 17x. Twice a number means 2 times the number, so that's 2x. 1/4 of any kind of fraction of a number, we multiply the fraction times the number. So 1/4 x or x over 4. Notice the x is treated as x over 1. So 1 over 4 times x over 1 would give us x over 4. Division, the quotient of 100 and a number. Always in the quotient, whatever is given first is on top and whatever is given second is on the bottom. So it's x, 100 divided by x. A number divided by 12 would be x divided by 12. And ratio of 5 to a number would be 5 divided by x. And notice, very often we're writing these this way. That should be an x over 12, and 5 over x. It's just, when typing, it's easier to use a slash mark to indicate division. Okay, we have steps involving an application problem. The first thing is to read the problem carefully. You may find you need to read through it a couple of times. Then assign a variable to represent the unknown. What you can do, you have a number of ways to set this up. You can say x equals whatever it represents. You can draw a picture, particularly if it's geometry, and label the sides of the triangle, the sides of the rectangle, or you can draw a table. If a table fits with a certain formula, you may find that's useful. But basically you want to represent the unknown and somehow organize the known information. So you may be representing the unknown, and then you may have a second quantity you represent in terms of the unknown as well. Next, you want to translate the problem. This is where you're going to use the phrases up above. You want to write an equation that expresses the problem. Once you get through those 3 steps, that's the hard part. Then you solve the equation as you normally would. You answer the question or questions asked in the problem. And then you want to go back and check your original answer, your answer in the original problem. You don't want to go back to your equation because your equation may be the problem. So maybe an error. So you want to go back to the original problem and check to see if your answer fits the requirements. Now, very often when I'm using a formula, such as these formulas you find in this table, I will use a table to solve the problem. So you have mixture problems, base times the rate. The percent is represented as a decimal, the rate. You have interest problems, principal times rate. Usually it's times time. In our book, they stick with 1 year, so they just leave the 1 out. Money problems, number times the value of 1 coin or 1 bill gives you the total value. Distance problems, sometimes called uniform motion problems, rate times time equals distance. So very often, if I have a formula involved, I will create columns. For example, column for base, a column for rate, and then a column for amount. A column for principal, a column for rate, and a column for the interest. You'll see that in some examples. So I'll be working some sample problems from the textbook for the sample problem portion. This probably will be one of those lectures where you definitely want to take a look at some sample problems, and we'll try to make sure we cover a variety of types of problems, so hopefully that will get you off on a good foot when you go to do the online homework.